Okay, there's my dog Lucky. No reason. There's my license on him so I can see how big he is. And, there's a statistical study that says that people tend to get dogs that look like them. I don't know if that's true in this case since I've got 3 different dogs. Maybe it's like a mashup of my 3 dogs. That's what I look like. Anyway, next time you see somebody and their dog, just check them out and see if they look like their dog. I think you'll find that there's definitely a pattern. Anyway, hey, let's do this thing where we're going to do a short video on what's coming up here. So let's get started. This one's on page 99. Now this is called a density curve. So in this case, took 947 7th graders and gave them a basic skills test, and these are their scores. Now you don't really need to know this vertical axis. All you need to know is that a bunch of them scored a 7 or a 7.5, and not too many of them scored an 11, and less of them scored a 2. There's only a few kids down there, right? So it's a general idea of how the kids did. That's what we do, just a general idea of what's going on here. So that's a density curve. And you would make a nice, smooth curve as much as you can through the tops of these things. You might say that this outside area could kind of fill in that inside area, right? If you cut these parts off and plugged them in right there, you'd fill it in, and you have a nice, smooth curve. Okay, so that's a density curve. Let's look at what they do with that. So in this figure, they're basically saying, well, look at this graph, right? If we fill in this area here, right? That's what it would look like. Nice, smooth curve. And we don't want to lose sight of the fact that this graph is from 947 kids and their test scores, okay? Now, if we look at a score of 6, what would that percentile be? Okay, so if you look at the graph, that's 100% of your data. So instead, we're just going to say this area is 1. So we would say that maybe from here, what percent of this data? Okay, 1 would be 100%, 0.5 would be 50%. They say it looks like it's about the 29th percentile, which means 29% of the kids, 29% of this area of the whole graph, 29% of the kids scored lower than a 6. That's what that is saying. Okay, let's go to the next thing. And here's a little bit of review. Remember, if we have a perfectly symmetrical graph like this, nice smooth curve, the mean and the median will be right in the middle. They'll be the same. Okay? And then if you have a skewed graph, where it's out here, these bigger numbers are going to pull the mean towards that skewedness, right? The larger numbers are going to affect the average, but the median still stays relatively in the middle. So think of this as equal areas, right? The median is the equal areas part, and the mean is the balance part, if you were to balance this thing. So look, if it's skewed, it's not going to balance right here. It's going to be a little bit further out, and that would be the balance point right there for this graph if you were balancing it on your pencil or whatever. So good stuff to remember. Let's look at the next thing. So here's a new thing, and that is if we have a normal distribution, that's what they call this, when it is perfectly symmetrical, nice shape like this, 1 standard deviation in each direction. How much area is that? Well, it's approximately 68% from here to here. Now, if you look from 2 all the way to -2, right, 2 standard deviations in this direction, 2 standard deviations in that direction, how much of the data is there? Well, it turns out it's pretty close to 95%. We just use this rule, this 68, 95, 99.7. That means that 3 standard deviations on either side, that includes 99.7% of your data. Okay? So, let's just say that you're at 1 standard deviation. What is the percentile for that? Well, if you're looking at the average, that's the middle, right? That if we cut this graph in half, this would be 50%. of the area. So that would be the 50th percentile. What's one standard deviation? Let's see. 68%, right? Cut in half is going to be 34%. So we're going to add that 50% plus another 34%, and you're going to be at the 84th percentile at one standard deviation. So if you go above one standard deviation, you're doing better than 84% of the people that did whatever you're talking about. Like, remember I said that golf tee shot or test scores or height or weight or anything like that. Percentile. We're going to work with that. So this might be a little bit confusing, but I think if you just watch this video and we'll do a little bit during class, I think you'll be able to get it.